Hi, my name is Natalie Tan Huan from University Tun Hussein of Malaysia and the Department of Electrical Engineering Technology, Faculty of Engineering Technology. Today, I would like to present on my final year project entitled Fertilizer Measuring Machine for Hydroponic Growing Industry. This project was together with my supervisor, T.S. Hasli bin Roslan. This presentation will consist of two parts. The first part will be the demo presentation and then the second part will be the poster presentation. So let's check out on my demo presentation video. I hope you enjoy my demo presentation video. So now I would like to present on my poster presentation. First and foremost, I would like to give a simple brief on what my project is all about. We found out that the traditional way of manually fertigation system requiring large number of workers and causing delay in fertilization. As in agricultural field, we concern on the fertilizer mixture ratio, and any errors will result in damage to plant growth and consequently causing serious losses to plant operator. Therefore, to prevent this problem, we figure out to develop tools to control the ratio of fertilizer measurement. Generally, we will be mixing fertilizer A and B, which are measured in tanks separately with the same ratio before being mixed. These fertilizers are measured using TDS sensor, and blink is applied on the monitoring process to ensure that the soil moisture level, temperature, air humidity are always in the right range. Other than that, this system is equipped with other equipment such as water level sensor, water pump, LCD and LED as an indicator on the system monitoring display, and we will be mainly using Arduino Mega as a microcontroller for the entire system. Generally, the fertilizer measuring machine will be invented according to the fertigation technology. As we concern on the fertilizer mixture ratio, an appropriate fertilizer level is necessary for the optimal plant growth. Therefore, the TDS level in the mixed fertilizer will take into consideration while developing the measuring machine. Thus, the objective of this project will be mainly designing the fertilizing tools that control the ratio of fertilizer. As the controlling process involves also the deliver function, therefore the primary motor used is the DC water pump, where two types of delivery mode will be applied, which are manually and automatically. The automated water pump controlling ratio process will be developed using pre-programmed water level sensors and water pump. Next, the second objective will be building a notification system using LED and LCD as indicator to monitor the water level in each tank and TDS level in the mixed tank. Goes on to the third objective, which is develop a monitoring system on the soil moisture, temperature, and humidity through online platform using Blink application. In order to make the monitoring system available on the online Blink platform, we will be using Node MCU ESP8266 to serially communicate with Arduino Mega to receive data and then update the received data onto the Blink Cloud server. As mentioned earlier, the Arduino Mega 2560 will be used as the brain in this measuring system in controlling the process of fertilizer flow and notification system monitoring process. Here shows some literature review ideas taken into the implementation of my project. Firstly, from Tiruna Wakasaru et al., the system used 5 water pumps to control the fertilizer delivered into mixing tank, which each connected to the normally closed terminal with relay. The idea is implemented by applying the same concept as 4 water pumps will be used to deliver the fertilizer, and the final destination is in the mixer tank. Secondly, from Epihiram MST ETL, the collected data will be transmitted to Blink server. The idea is implemented in the project by using Blink application for the purpose of monitoring condition of vegetable plants. From the same author, the use of DHT11 sensor and soil moisture sensor for monitoring the condition of crop yield. The idea is implemented from the same reason. From Muhammad Kari Idham Abdul Rahman ETL, the use of easy meter in measuring the nutrient content of mixed fertilizer. The idea is implemented and by replacing with TDS meter to measure the total solid dissolved in the mixer fertilizer. In this section, I will be presenting on the method used in developing the measuring system. The Arduino Mega 2560 microcontroller will be programmed with Arduino IDE software. The main input sensors will be the water level sensor and TDS sensor. As shown in the figure 2, 4 water level sensors located in each water tanks and measuring tanks, while the TDS sensor located in the mixer tank. Each water tank and measuring tank will have 2 LED indicators, and the mixer tank will have 3 LED indicators as the notification system. All the DC water pump will be controlled by 2-channel relay, which 2 water pump located in the water tank will be controlled manually, while the other 2 water pump located at the measuring tank will be triggered automatically. There will also be the soil moisture sensor and DHT11 sensor to monitor the conditions around the plant. In this session, I will be showing the result and discussion for 4 tests. The first test result will be on the water pump functionality. As shown in the result, the functionality of DC water pump in both tank A and B was consistent with no huge fluctuation. For example, we can take a look in figure 3 over the 15-second time duration. From the blue bar chart and orange bar chart, we can see that the output is constant. In contrast, the speed of water pump is not stable at the first 5 and 10 seconds in both tanks as compared with the more constant speed at 15 seconds and 20 seconds. This might be caused by the pipework pressure loss or the power supply voltage, as the power is supplying to 4 DC water pump. But this minor difference will not give much impact to the system working. Next, the second test result will be on the performance of automated water pump. As shown in figure 5, the average time taken for water pump measuring in tank A to completely deliver the 500 ml into the mixer tank was 30 seconds, while for the water pump in measuring tank B was 20 seconds. The purpose of carrying out this test is to take the average time taken to make a delay timer for automated water pump before turning off. As mentioned earlier, the automated water pump will be triggered by the signal detected by water level sensor. So for instance, we take the water pump in measuring tank A, which we will set the delay timer for 30 seconds. So the automated water pump will be keep turning on for 30 seconds to ensure the measured ratio completely delivered to the mixer tank. The third test result will be on the TDS value on mixing variance ratio. This test will be carried out 11 times, starting with ratio of 10 to 0 and then slowly increasing until the last test is the ratio of 10 to 10, or normally known as ratio 1 to 1. So at the end of the line chart in figure 6, we could see that the ultimate TDS level in the ratio of 1 to 1 or 10 to 10 is around 550 ppm. So this ratio is still within the required TDS level range for the optimum plant growth for hydroponic vegetable plants. But we also can see that even without the ratio of 1 to 1, we can still get around 560 ppm. But in order to maintain the balanced nutrient from both fertilizer, the ratio of 1 to 1 is still more considerable. The last test result will be on the monitoring system through Blink platform. As in figure 7, we can see that there's 3 charts, which is the data taken during daytime and nighttime in the categories of temperature, humidity, and soil moisture. So as a result, during daytime, the temperature is higher and humidity lower because of the daytime sunlight, and also lack of humidity because causing temperature high. Other than that, there's a huge fluctuation difference in soil moisture level because the plant undergo a day of absorption and evaporation. As a conclusion, this measuring machine will be able to provide convenience and increase the efficiency of production with simple actuator and sensor. All the objectives were successfully achieved by the fertilizer measuring tools developed by using pre-programmed water level sensor and water pump. Next, the monitoring system on the temperature, humidity, and soil moisture through Blink platform was successfully developed by serial communicating between Arduino Mega and Node MCU. The notification system also built using LED indicators for each tank and LCD display for water level and TDS level. As the overall conclusion shown in the result, the ratio of 1:1 from each fertilizer A and B able to reach the optimal TDS level of 550 ppm. The water level sensor in measuring tank will be placed at the required level to automatically turn on the water pump when detected level reach, and then it will setting a delay system at 30 seconds for measuring tank A and 20 seconds for measuring tank B before the water pump turn on to ensure the required ratio have been delivered to the mixer tank. Here shows a few recommendations in order to improve the fertilizer measuring machine. So firstly, we can modify the whole system to fully autonomous using the timer techniques. Secondly, we could modify also the system into wirelessly controlled system when detected soil moisture level is low. And tertiary, we could replace the water level sensor with ultrasonic sensor in the main tank and also replace the water pump to solenoid valve in the measuring tank. And then lastly, the recommendation is adding the function of storing data and data analysis into the monitoring system. And lastly, this is the reference I referred to during implementation of my project. So that's all from me. Thank you.